So the question is saying a circuit comprising two resistors and two batteries, as you can see, two resistors. So let's suppose this is the resistor R1 and this is the resistor R2 with the two batteries. So this is the 6-volt battery, this is the first, and this is the 3-volt battery with negligible internal resistance is set up as shown in the diagram. The two junctions in the circuit are labeled X and Y. So you can see this is the first junction X and this is the second junction Y. What are the magnitude and the direction of the current in the 3-volt battery? That's a very important question. What should be the direction and magnitude of the current in the 3-volt battery? So we have to find basically the direction and magnitude of the current in this battery. It may be in this direction or that direction. Yeah, so what we can do? Do you have any idea?
So the conventional current usually flows from the positive to negative terminal. So would it be from Y to X?
No, see. Okay, see, in this case, what we can apply here? We can apply the superposition theorem. Have you heard the superposition theorem? We want first.
I don't think so, sir.
See, I want the voltage here and voltage here, right? Okay, so first let us assume first that this 3-volt is not applied here. So if ideal voltage source can, if the superposition theorem is this. Suppose you have only this 6-volt, then analyze this circuit, then after that you have only this 3-volt, then the response should be added. So when we are considering this 6-volt battery, this 3-volt battery should be treated as a short circuit. You can say this will be a short circuit. Now please try to find what is going on in this circuit. Now you have the 6-volt battery and we have the two resistors, 1 and 3 ohm, and I think this can see when you will short this battery, this R2 and this R is equals to 0. This branch has 0 resistor. Now this R0 and 3 ohm becomes in parallel, and if you will find 0 parallel with 3 ohm, you will get the 0. So basically this 3 ohm resistor loses its significance. There is no there will be no any difference due to this 3 ohm because this is shorted in parallel. Are you getting my point? Whenever any current comes here, see here, whenever any currents comes from this battery, okay, this will proceed in another direction. Okay, so whenever any currents come from this direction, here, so it will move in this direction. The complete direction will go in this manner. There will be no current flow in this direction. Are you getting this? Why it is so? Because you know that current takes the shortest path. Do you know this or not? Are you getting this, Anukam? What I am saying?
Yes, sir.
So
current always takes the path of least resistance.
Yeah,
right?
very good. So whenever you have a short circuit in parallel, so this resistor will not get any current. All the incoming current in this Y junction will go in this direction. So what we are getting here? So here no resistance. So the current in the circuit will be I equals to V upon R. So overall 6 ampere should be flow here. So 6 ampere current is flowing in this direction. Are you getting my point? First, now, is it okay?
Yes, sir.
Now what I will do, I will now remove this 6-volt battery and apply the 3-volt battery, and just let us see what is going on. See, so now I am removing this 6-volt battery. So if you want to remove this battery, it means this is going to be a short circuit, and now this comes in picture. This 3-volt comes in picture. So I think current will start from this direction. Right, current will start from this direction. So it has two options. It will either flow in this direction or in this direction. So can you analyze that? Now these two resistors are in parallel. Are you getting, Sanuka, that these two resistors now are in parallel? 1 ohm and 3 ohm resistors are in parallel now. Are you getting this or not? Please let me know first.
Yes, sir.
Yeah. So first of all, let us find the equivalent resistors. What will be the equivalent resistance for this 1 parallel with 3? So it should be 1 into 3 upon 1 plus 3. So it should be 3 upon 4. So the overall resistance of these two parallel resistors will be 3 upon 4. So how much current it should be? How much current should be? I is equal to V upon R. So I is 3 upon R is 3 upon 4. So it will go in the numerator. So you will get the 4 ampere, right? So it means 4 ampere is going in this direction. So it will go like this, It means 4 ampere it will come in this direction. So this is the direction of 4 ampere in this xy branch. Are you getting
Got
my
it.
point?
Yes.
Are you getting my point? And from earlier calculation we got that
Yes, sir.
6 ampere was flowing in this direction. In the earlier calculation, see, when we have considered only 6 volt initially, you got that the 6 ampere was flowing in this direction. See, initially current was flowing in this direction. This is the positive terminal, right? So in the xy branch, initially we have the direction of 6 ampere from y to x. Is it okay? So now just superimpose both the result.
Sir.
Now,
Yes.
yeah, so now we will have a net current of 2 ampere from y to x, isn't it? See, is it okay? So now
Yes,
when
sir.
we apply both the batteries, so now you will have 2 ampere of current from y to x. Are you getting this? Any doubt? You can ask.
Yes.
Please write if you are writing something.
No doubt, sir. I
Okay,
understood.
okay, okay. So this is called basically superposition theorem. Okay, we can we have some other concept on superposition theorem as well, but this is sufficient for this question. Okay.